Hi, I'm Will Greenwald, Home Entertainment Editor at PCMag.com, and I'm here to show you how we test TVs in the PC labs. We test TVs based on methodology using Imaging Science Foundation's calibration techniques. I'm an ISF Level 2 certified calibrator, and this is some of the pro equipment we use. This is the Klein K10A Calorimeter. It is a very expensive metal tube that you point at anything that emits light, and it shows you very precise measurements of how much light it puts out and the color of that light. In this case, we use it to find out the actual contrast, the peak brightness and darkness, and crunch the numbers like that from a TV, and each color, how accurate it is compared with BT709 and BT2020 color standards. This is a Muradeo test pattern generator, the 6G. It is a box we plug into the TV that actually puts out the accurate signal of red, blue, green, all the colors, the brightness, the darkness, so we can get the right numbers with the Klein. And this little red box is a Leo Bodnard input lag tester. It has a small light sensor and outputs a flashing pattern onto the TV. You pop it up on the TV and it actually measures how long it takes for the panel to refresh once it sends a signal. So when you're playing a video game, you don't want it to take like a tenth of a second between the system sending out a signal and doing something. That's going to ruin your game. But with this, we can see if some TVs are 20 milliseconds, 15 milliseconds or less, and those we consider our best gaming TVs. So we're going to walk you through the whole testing process right now. Now, we don't actually calibrate these TVs to review them because we want you to know what the TV is going to be like when you get it out of the box. So we go through what's called a very simple darkroom semi-calibration. We don't adjust colors, we don't go into any heavy menu settings. We just go into the right mode on a TV to give you the best sense of a preset that's the closest to the cinema setting. In this case, for a Sony TV, we go into picture modes. It's currently at Vivid, Standard isn't good, Custom, Cinema Pro or Cinema Home are good for starting testing. Then we go through other settings and basically tweak a couple different things to make sure that we're getting the most accurate numbers. TVs can change a lot of stuff in image processing, motion control, sharpening. A lot of the things they do to seemingly enhance contrast can sort of change the numbers we get. So we basically go through all of them and make sure that what we're getting is the most accurate measurement we can. This isn't a totally accurate calibration. We don't test color besides setting it to the warmest color setting. In that case, it is in the advanced settings. Expert 1 is one of the warmest. For most TVs, it is considered warm, but you can see a little bit blue, a little warmer. And Expert 2, they're very similar. The warmest color temperature setting, it might look a little bit yellow-orange to your eyes if you're used to the very blue lights of the TV you might have seen in the store, but the warmest color temperature setting we've seen actually produces the most accurate color results without any other calibration. Now you can see on the tripod, the colorimeter is pressed right up against the screen. There's a rubber gasket that makes sure light doesn't leak out, and we usually test in a very dark room, but we can't record anything when it's dark, so we start with contrast measurements. So what we do is we load it up, move everything here, make sure the Muradeo is attached, and press this button, and it starts measuring. This is a chart of the luminance at different levels of very close to white shades of gray. And here is the peak brightness in this current picture mode with the current viewing situation. 174.04 candela per square meter, or nit. That is not very bright, but again, this is not a TV we're currently testing, and these are not specifically the conditions we test under. Darker room, much more controlled. Light leakage can do a lot of things to the numbers. But now we have the peak brightness. Now to test black level, we do basically the same thing, but have a very dark pattern on the screen. In this case, we have a window pattern. If you have a completely black screen, then sometimes this screen just turns off. It's just what the TV does electronically, so it'll show you completely dark, but it doesn't give you a sense of what the contrast is going to be or what the black level is when the screen's turned on. So we need something on the screen while we measure black levels, and then we perform a similar test with a click. And it gets us the black levels. 0.35 nits is very high black level, but again, we got bright lights for video. The gasket is not pushed quite snug up in this current situation, so light is leaking in overhead. When we do testing, we do it in a very dark room that you wouldn't be able to see if we were trying to record it. So these are the black levels, and after that, now that we have the peak brightness and the black level, we divide the peak brightness by the black level and calculate the contrast ratio, which is basically the full span of the brightest the screen can get and the darkest the screen can get at the same time. These two charts are what is known as pluge charts. They show a series of very close to white and very close to black and black levels, so you can actually measure each value that the TV can process and make sure nothing is clipping, which means when it hits a number and then it cannot actually produce shades of gray above it. Everything becomes black or everything becomes white. We do minor calibrations with the brightness and contrast settings on a TV just to make sure that this is actually giving the full range and is rendering all of the shades of gray that it should be able to before we start taking measurements. It isn't a full calibration, but it does let us make sure that we're getting good numbers for the setting you want when you're actually watching TV. So you get all the details and that nothing clips or is engulfed by shadow. For color measurements, we do a similar thing. We put up the brightest colors on each end, red, green, blue, and then the intermediary colors, cyan, yellow, and magenta, and white, and take the numbers and compare them to how close they are to this triangle. This is currently showing BT 709 or standard definition colors, and this larger triangle is BT 2020. So we compare both the standard color range and the much wider color range, and just see how far each TV can reach. So let's see how this fares in HD versus BT 2020. But you can see red comes very close, green pretty good, magenta, blue, cyan, yellow, and we want to see how it looks compared to BT 709. We just change the color space and compare the numbers. We can also limit the values to only reach BT 709 and see how accurate they are when you're just looking at broadcast media, not wide color gamut, not HDR. And out of the box, a lot of TVs actually get pretty close these days, which is impressive. After we have all the scientific numbers, we then take some time and watch movies and TV shows on the TV to actually have a good sense of what the viewing experience is. So if you decide to get it, you know what you're in for and whether it deserves a Redditor's choice, which is why you should read all of our TV reviews.